This will be for the Khan Academy unit test, composite and inverse functions. The following table shows a few inputs and outputs of f of x. What is the value of inverse f of 93? Okay, this -1 is not an exponent. This is inverse f of 93. So if you had f of 93, you would look up x equals 93 and get the y value. But remember, for the inverse function, the x and y are reversed. So in this case, we're looking up the x value when y equals 93. All right, so this row is the x values, and this row here are the y values. Okay, f of x is the same as y, so we go to y equals 93. That's this right here, and the respective x value is 87. So when y equals 93, x equals 87. Final answer. All right, so just click inside the box and type 87. A submarine is diving toward the bottom of the ocean. The depth D of the submarine in feet below sea level after t minutes have elapsed is given by this function here, d of t. The pressure P in pounds per square inch exerted on the sub at a depth of x feet is given by the function P of x equals this function. Which expression models the pressure exerted on the sub as a function of the elapsed time t in minutes? Okay, let's see. So we're looking to find the pressure on the sub as a function of t. So in other words, it's going to be P of t, okay, because we have the pressure right here, but we want it in terms of t in minutes. All right, so we are looking to find P of t. All right, the pressure in terms of the time. The pressure as a function of the time. All right, we have the pressure here, but this is in terms of x. All right, that's depth of x feet. Now, this one is in terms of time t, and this function is the depth d. So if x is the depth and this function here is the depth, we can take this function and plug it in for x. All right, so you want to take that function and plug it in. All right, that's why it's a composite function. It's a function within a function. All right, so P of t, we're rewriting P. We have 14.7. All right, we have 14.7 plus 0.445. And that 0.445 is times x, but x is being replaced by this expression, 20 plus 16t. All right, let's see. We still have 14.7 and distributing 0.445 times 20. Let's see, times 10, it will be 4.45, and then times 2, that would be 8.90. And distributing 0.445 times 16t, let me do it on the calculator. All right, I got 7.12t, and now combining like terms, 14.7 plus 8.9. Neither of those have variables, so 14.7 plus 8.9, I get 23.6, and we still have 7.12t, and that is your final answer. We now have pressure based on time t as a function of time t. Answer D. Functions f and h are invertible functions. Answer 2 questions. Write a simplified expression for f of h of x in terms of x. Okay, f of h of x means we take h of x and plug it into the f function. So that's what I'm going to do first. All right, we're looking to find f of h of x. So you take the f of x function and you replace all the x's with the expression for h of x. We're taking h of x and plugging it into the f function. So h of x is this right here, and we're taking that entire expression and plugging it in place of x. All right, so here we go. F of h of x. We're just recopying, and wherever there's an x, we sub in this. So we have 11 minus x is going to be replaced with negative 4 parentheses x minus 11. And that x is divided by 4, so this whole thing is divided by 4. All right, and let's see. We have 11 minus, and distributing, negative 4 times x is negative 4x. And let me see, hold on a sec. All right, this minus is applied to this whole thing. So let me use parentheses here so we don't get confused. All right, because again, this minus is applied to this entire fraction. So distributing, negative 4 times x, negative 4 times negative 11 is positive 44. And that whole thing is divided by 4. All right, let's see. All right, we have 11. And now we have to distribute the negative sign. Minus negative 4x is going to be positive 4x. And minus positive 44. And that whole thing is divided by 4. Okay, we have 11. We have a common denominator. 4x divided by 4 is just x. And negative 44 divided by 4 is negative 11. Remember, when you have a common denominator and you cancel, that denominator is applied to both terms in the numerator. All right, so we have 11 plus x minus 11. All right, and now combining like terms, 11 minus 11 is gone, and we are left with x. Perhaps an easier way to do this, if I just distributed, since this is negative times negative, we could have made this positive right off the bat, and then distributed positive 4x. We would have got the same thing. All right, so f of h of x is just x. That's it. And now, are functions f and h inverses? Yes. As long as you get x, the answer is yes. All right, this is for x only. No is anything other than x. All right, so if they asked f of h of x, or if you did h of f of x and got x, the answer is yes. All right, so x only for the yes. F is a finite function whose domain is the letters a to e. The following table lists the output for each f's input in f's domain. All right, so this is the function f of x. We have the x's and the y's. Answer 2 questions. Build the mapping diagram. All right, so just a click and a drag. All right, a is 61. B is negative 31. All right, so A is here. A is 61. B is here. That is associated with negative 31. C is 71. D is 101. Okay, C is 71. And D right here is 101. I'm assuming it's down here. D is, whoops. D is this one. That's 101. And finally, E is negative 11. All right, so this one is E, and that goes to negative 11. And a follow-up question here. Not sure why I can't see it. They're asking, is f, the function f, invertible? And you basically have to say yes or no. So let's see if it's invertible. The domain is this side. These are the x values, and the range right here, these are the y values. Let's mark that. Now, to prove that something is a function, each x value has to have only one y value. So let's write that out. Each x has only one y, so that's a function. Now for the inverse, or to test if it's invertible, you have to test the opposite of this. So each y has to have only one x. All right, so it's the opposite of a to prove that it's a function. Because for the inverse, you flip or swap the x and the y. So now each y has to have only one x. So the negative 31 goes to B only, negative 11 to E only, 61 to A only, 71 to C only, 101 to D only. So the answer is yes, it passes the test. All right, so in this case, it's yes. Now, let's say, for the sake of argument, negative 31 went to B, but negative 31 also went to C. Then in that case, the answer would be no. All right, but that's not the case for this one. Okay, each y has only one x, so the answer is yes. To prove that it's a function, each x has to have only one y. For the inverse, it is reversed. So the answer is yes, f is invertible. All right, I think I spelled invertible wrong, I-B-L-E. I think I did A-B-L-E. Anyhow, the answer is yes. Okay, we have our functions f of x and h of x. They want us to write h of f of x as an expression in terms of x. Okay, remember now, when you see this little circle, you could think of the word of. So this is h of f of x. All right, so it's basically h of f of x. All right, so we are taking f of x and we are plugging it into the h function. So wherever there's an x in the h function, it gets replaced by f of x. All right, so f of x expression is this right here. And wherever we see the x in the h function, we are plugging in that entire expression. All right, so I'm going to do my work right here. We're finding h of f of x. I don't have room to write it, but we're just recopying this. All right, so we have the cube root. All right, we have the cube root, and x is replaced by x to the third plus 5. And x is minus 5. All right, so underneath the radical, 5 minus 5 cancels. And we have the cube root of 8x to the third. All right, so just so you can see it better, I'll break this up. The cube root of 8x to the third is the same as the cube root of 8 times the cube root of x to the third. All right, so cube root means what multiplied 3 times will give us 8. Well, that's just a 2, right? I can replace 8 with 2 times 2 times 2. And we have the cube root of that. And we're also asking what multiplied 3 times will give us x to the third. I can replace x to the third with x times x times x. All right, that's a cube root. All right, since it's a cube root or the third root, you cancel the number that repeats 3 times. So I have 3 2's here. I can cancel the 3 2's and pull one outside of the radical symbol. And here we have 3 x's multiplied. I can cancel the 3 x's and pull that outside of the radical symbol. So 2 times x is just 2x. Okay, this was an unnecessary step. I just wanted to unpack these and show you what I was doing. But the cube root of 8 is 2 because 2 to the third is 8. The cube root of x to the third is x because x to the third is x to the third. All right, so that is just 2x. Function f graphed below is not an invertible function. To which intervals could we restrict the domain to make it invertible? Choose all answers that apply. All right, so to see if a function is invertible, it must pass the horizontal line test. So to test if the function is invertible, you want to do the horizontal line test. It must not intersect more than once, okay? It can't intersect the graph more than once. So obviously, if we did it like this is not invertible because if we do the horizontal line test, it fails. It intersects the graph more than once. But we can possibly restrict the domain or the x values, and that portion will be invertible. Let's see. Here where we are restricting x between 8 and 0, okay? This has the bar underneath the inequality, so it includes the 8 and it includes the 0. So let's see, restrict it from 8 to 0. Go to your x-axis, 6, 7, 8 is right here. And x-axis again, 0 is right here. So we are restricted in this range, or domain, I should say, only. Okay, so make sure it does not intersect more than once. If we do it here, it only hits once. If we do it here, once. Here, once. Okay, so in this domain right here, it passes the test. It does not intersect more than once. It passes the test. So in that case, it is invertible between 0 and 8. All right, so let's click that one. Next up, between 1 and 6. Okay, it has the equal sign, so it includes 1 and 6. All right, so we're going to x equals 1. On the x-axis, here's 1. And on the x-axis, here's 6. So between 6 and 1, and it includes 6 and 1. Okay, and if you do the test, the horizontal line intersects it once, no matter where you go, it intersects it once. Okay, so between 1 and 6, that part also works. So if we do it between 1 and 6, we're good. Now between -4 and -8, and it has the equal sign, it includes both. So if we go to -4 on the x-axis right here, and -8, here's 5, 6, 7, 8 right here. Okay, so we are restricted to this domain between -4 and -8. And I can tell already that it's going to work. Okay, horizontal line, no matter where you draw the horizontal line in between these pink bars, it works. Okay, it does not intersect more than once for each horizontal line. So that one also works. And that is all answers that apply. Okay, it might be more than one when it says all answers. The graphs of equations y equals f of x and y equals h of x are shown in the grid. Which of the following approximates f of h of negative 5? Okay, so what they are asking here, remember the little O symbol, that means of. So this is f of h of negative 5. Basically, f of h of negative 5. All right, so first we want to evaluate h of negative 5. So we have to look for x equals negative 5 and find out what y equals. Now we're looking at the h function first. This one's f, this one's h. All right, so we want to do the h function first. All right, so we go to x equals negative 5 and trace it to the h function. X equals negative 5. Okay, trace it to the h function, and it meets it right there. And we want to know the y value, and that's going to be negative 2. So the y value of h of negative 5, that's negative 2. All right, so now we're going to the f function, and it's just going to be f of negative 2 because h of negative 5 was negative 2. All right, and again, this is going to be x equals negative 2 and y equals something. All right, so let's go to the f function this time. X equals negative 2. Let me erase this mess. X-axis, negative 2, is right here. We are looking at the f function, which is this one. Trace it up. Hits it, intersects right there, and the y value is positive 3. Final answer. Answer D, f of h of negative 5. All right, so h of x and g of x, Danielle tried to evaluate g of h of 7, but she made a mistake. Here is her work. Where is the mistake? Okay, so I think these mistake-type problems, it's best to do it yourself and then compare to the other person's work. All right, so this is g of h of 7. All right, we're looking at g of h of 7. All right, so first we need to evaluate h of 7. We're going to use the h function for that. So h of 7 means you're going to plug in 7 in place of x. So the 7 goes right in there, and that's just going to be 9 times 7, which is 63. All right, h of 7 is 63, so replace h of 7 with 63. So now it's going to be g of 63. And what that means, we go to the g function now, and we're plugging in 63 in place of x. All right, so g of 63 is going to be 3 over x minus 2. So that's 63 minus 2. All right. And 63 minus 2 is 61. So that's the final answer. Let's see where she made the mistake. All right, h of 7 is 63, and for some reason she did g of 7, so right there, that's the mistake. All right, step 1 was to find h of 7, and she did g of 7. So step 1 is her mistake. Let me see. All right, this one is actually not based on steps. This is based on what she did overall. So she did g of 7, and she did h of 7, and then she just took each answer and multiplied it, 3/5 times 63. So that's the mistake right there. G of h of 7 does not mean you multiply them. Okay, so that was the mistake. G of h of 7 equals this, not G of 7 times h of 7. So clearly that's what she did. Here's G of 7, here's her h of 7, and she just multiplied them. So that's no good. All right, f is a finite function. The domain is the letters a through e, according to this table. Build a mapping diagram. Okay, we did one like this. A is -6, B is +3. All right, A is -6, B is +3. C is -6, D is 2. C is -6, D is 2. And finally, E is -6. E is -6. All right. And they want to know, is the function invertible? Yes or no? All right. So we said this before. This is the domain, and this is the range. So the domain is the x values, and the range is the y values. Now, to prove it's a function, each x has to have only one y. All right, each x has only one y. But for the inverse, you swap the x and the y. You reverse the x and the y. So now it's going to be each y has only one x to check if it's invertible. If not, then it fails. Okay, we can see the y's right here. If you look at this y equals -6, it might be E, it might be C, it might be A. Okay, that's no good. So does each y have one x? No. All right, so in this case, it is not invertible. The one we did before was okay. This one is not invertible. Answer B. All right, function f is not invertible. It's a quadratic function. Which intervals could we restrict the domain and make it an invertible function? All right. So horizontal line test. It must not intersect more than once for the horizontal line test. All right, so let's take a look. X is less than or equal to 0. It has the equal sign, so it includes 0. All right, x is less than or equal to 0. So if we cut off the graph, here's x equals 0, this right here. And we do the test on the less than side. Okay, everything less than or equal to 0. And you can see here, if you try the test, it only hits it once. Everywhere you go, it only hits it once. Even way down here, it's only once. As long as it's not more than once, you're good. Okay, so for x is less than 0, less than or equal to 0, it passes. So the first one is good. X is between -4 and 4. It includes both -4 and 4. So let's cut off the graph between x equals 4 and x equals -4. Okay, so we're going to cut off the graph here. And we're between these pink lines. All right. And I can see already it's not going to work. If you draw a horizontal line between these pink lines, intersects the graph here and here. All right. It must not intersect more than once. Already we got it twice. So for this section, this domain, it's a no. All right, so this is no good for answer B. We leave B alone. C, x is greater than or equal to 0. All right. So here's x. X equals 0 is right here. This line in pink is x equals 0. We're doing everything greater than or equal to 0. All right, and I think it's going to work. If you do the horizontal line from here, only once, only once, only once. No matter where you go, it's only once. Okay, it must not intersect more than once for each horizontal line. This one passes. So answer C is good. Choose all answers that apply. Might be more than one. All right, so there you go. For the unit test, they don't include everything on each unit test. You really should take it at least twice because they're going to give you different problems when you take it the next time around.